Hello! Welcome to a new section of this course, Parallel and Reactive Streams. In this section, we will cover about creating streams from different sources, reducing the elements of a stream, and collecting the elements of a stream. Then, we will apply an action to every element of a stream and filter the elements of a stream. Also, we will transform the elements of a stream, sort the elements of a stream, and verify conditions in the elements of a stream. Finally, we will look into reactive programming with reactive streams. Now we move on to the first video of this section that deals with creating streams from different sources. In this video, we'll implement an example where you will learn how to create streams from the sources described earlier. A stream in Java is a sequence of elements that can be processed, that is, mapped, filtered, transformed, reduced, and collected, in a pipeline of declarative operations using lambda expressions in a sequential or parallel way. It was introduced in Java 8 and was one of the most significant new features of that version, together with lambda expressions. They have changed the way you can process big sets of elements in Java, optimizing the way the language processes those elements. Streams have introduced the stream, double stream, int stream, and long stream interfaces, some utility classes such as collectors or stream support, some functional like interfaces such as collector, and a lot of methods in different classes, such as the stream or parallel stream methods in the collection interface or the lines method in the files class. The example of this video is implemented using the Eclipse IDE. You can use any other of your choice. Create a new project and give it a name of your choice. First, we'll implement some auxiliary classes that we will use in the example. Create a class named Person, implementing comparable interface parameterized with the Person class. Here, we import java.util.date, which we'll require in this class. Also, we create 6 attributes of different types: string, int, double, and date. Add this block of code. Don't rush. I will explain you each part of it. Here, we created the methods to set and get the values of these attributes. We have used the toString method to return the first name and the last name. We implement the compareTo method to compare two person objects. Let's consider that two persons are the same, if they have the same first name and the same last name. After this, we add the equals method, which has a Boolean type, and the hashcode method with the int type. Then, we create a class and name it as PersonGenerator to create a random list of person objects. We import the Java libraries which we would use throughout this class. Within this class, we implement a static method named GeneratePersonList, which receives the number of persons you want to generate and returns a listPerson object with the number of persons. Here, we include a version of this method, but feel free to change it. Now, create a class named MySupplier and specify that it implements the supplier interface parameterized with the string class. Import the required Java libraries. Next, we declare a private atomic integer attribute named counter. After this, create the constructor of the class and initialize it in this constructor. Once this is done, implement the get method defined in the supplier interface. This method will return the next element of the stream. Here, we used an implementation of the supplier interface, the MySupplier class. The interface provides the get method. This method is called each time the stream needs an element to process. Now create a class named main and implement the main method in it. As usual, we need to import the required Java libraries, along with the Java class that we created earlier. Within the main method, add these lines of code. First, we created a stream object from a list of elements. We created the PersonGenerator class to create a list of 10,000 person objects and use the parallel stream method of the list objects to create the stream. Then, use the count method of the stream object to get the number of elements of the stream. As you can see, we use the parallel stream method of the list class. In fact, This method is defined in the collection interface. So all the classes that implement this interface, such as the ArrayList, LinkedList, or TreeSet classes, implement that method. You can use the stream method to create a sequential stream or the parallel stream method to create a parallel one. We prefer to use the parallel stream method. Then, we create a stream from a generator. Here, we create an object of the MySupplier class. Then, use the static method generate of the stream class, passing the created object as a parameter to create the stream. Finally, use the parallel method to convert the stream created to a parallel stream, the limit method to get the first 10 elements of the stream, and the for each method to print the elements of the stream. Let's add the next block of code. Here, we create a stream from a predefined list of elements. Use the static of method of the stream class to create the stream. It receives a variable number of parameters and returns a stream with those parameters as elements. In this case, we pass 3 string objects. Then, we use the parallel method of the stream to convert it to a parallel one, and the for each method to print the values in the console. We create a stream to read the lines of a file. First, create a buffered reader object to read the file you want to read. Then, use the lines method of the buffered reader class to get a stream of string objects. Each element of this stream will be a line from the file. We also have the parallel method to get the parallel version of the stream and the count method to get the number of elements in the stream. Don't forget to close the buffer reader object. Our next step is to create a stream to process the contents of a folder. First, we use the list method of the files class to get a stream of path objects with the contents of the folder. Then, we use the parallel method of the stream object to convert it to a parallel stream, and the count method to count its elements. Finally, in this case, we have to use the close method to close the stream. The next source we use is an array. First, we create an array of strings. Then, use the stream method of the arrays class to create a stream from the elements of the array. Finally, we use the parallel method to convert the stream into a parallel one, and the for each method to print the elements of the stream to the console. Let's add the next block of code to create a stream of random double numbers. First, we create a random object. Then, use the doubles method to create a double stream object. We pass the number 10 as a parameter to this method, so the stream we're going to create will have 10 elements. Or, in other words, we pass to it the size of the stream we wanted to obtain. But you can also pass to it the minimum and maximum numbers you want to obtain. Finally, use the parallel method to convert the stream into a parallel one, the peek method to write each element to the console, the average method to calculate the average of the values of the stream, and the getAsDouble method to get the values stored in the optional object returned by the average method. Finally, we create a stream concatenating 2 streams. First, we create 2 streams of string objects using the of method of the stream class. Then, we use the concat method of the stream class to concatenate those streams into a unique one. Finally, we use the parallel method of the stream class to convert the stream into a parallel one, and the for each method to write all the elements to the console. Now, in a code editor of your choice, open the project folder. Within your project folder, add a new folder, and we name it as Data. Within this folder, create a new file and name it as nursery.data. In this file, we add these lines of data. Now save this file and move back to your project file. Once you are here, save the changes and click on Run. Let me enlarge the console window. So, now you will be able to see the output of the code we had written. Nice! In this video, we saw how to create streams from different resources.